In this video, we are going to discuss this result that says that any Mobius transformation fixes one, two, or all points of the Riemann sphere, the extended complex plane. This means that if we have two copies of the extended complex plane, one or two points may remain fixed. But if there are more than 2 points, then all of them remain fixed. That means in that case, the transformation is the identity. That's the only possibility if we are to keep all the points in place. How do we prove this? Well, this is actually easier than it sounds. We just need to realize that a point is fixed if and only if it coincides with its image, which is given by AZ plus B divided by CC plus D. Okay, but then moving this to the other side, we find out that this reduces to a quadratic equation. So this is CZ squared plus D minus A Z plus, minus B equals 0. And here we just need to see how many solutions we have. Let's say C different from 0. In this case, we have A minus D plus minus a square root of D minus A squared, right? Plus 4CB divided by C. Notice here, C different from 0. And this has one or two solutions. In C. Okay, here it's not a problem if the discriminant is negative. We'll get a complex number, but that's what we are doing. Okay, so no big deal. The only case that you could think it's a little different is if, for example, we have equal 0, right? So if this is equal to 0, D minus A squared plus 4BC equals 0. This is one solution, otherwise two solutions. Okay, so that's one case. Now we need to analyze the other possibility that C equals 0. What happens in this case, looking at this equation? Well, this term is not there, so we have D minus A Z minus B equals 0. And here we can clearly say, okay, so let's solve for Z. But careful there are two options. Either A different from D. Okay, in this case, Z equals B over D minus A. Okay, and what did we find? We have found that the transformation fixes 2 points. You could say, hey, but you just found one. What is the second point? The point of infinity. Okay, how come? How is that? See, P of Z equals AC plus B over CC plus D. This term is not there, okay? So that means this is A over D, Z plus B over D. So T of infinity equals infinity. Okay, and then we can also check that this point remains fixed. But that's only the first case. There are two cases here. All right, the second case is what? A equals D. Okay, so in this case, things get a little, they get easier, but also a little bit strange, right? Because this term is 0, so then B is also 0. So, okay, lots of things happen now because we have C0, B0. So T of Z is AZ plus B divided by what? Z, C, Z plus D. We have that B is 0, C is 0, and this is A over D, whoops, D times Z. But we just said that A is equal to D in this case, so this is equal to Z. This is the identity, okay? The identity fixes all points. And this completes the proof.